Good morning, students. Today we will study about electrochemical cell. So what is electrochemical cell? Electrochemical cell means those cell in which chemical energy is converted to electrical energy. The cell in which chemical energy is converted to electrical energy is called electrochemical cell. That means by doing some chemical reactions, that chemical energy you can convert to electrical energy. I mean, by doing some chemical reaction you can produce electricity, and that type of cells are called electrochemical cell. Now if you want to construct an electrochemical cell, how do you construct it? To construct the electrochemical cell, you can construct in lab also. Suppose this is a container, and the container contain a solution which should be electrolytic solution. Suppose this solution is zinc sulfate solution. I mean the solution contains Zn2 plus and sulfate ion, and in this zinc sulfate solution a zinc rod is dipped. So this is the zinc rod. I mean a zinc rod is dipped in zinc sulfate solution, and similarly this is another container, another beaker, and here another solution is present. This solution is suppose copper sulfate solution. I mean here copper 2 plus and sulfate ions are present, and in this copper sulfate solution you dipped one copper rod. This is the rod of copper. So a zinc rod is dipped in zinc sulfate solution, and a copper rod is dipped in copper sulfate solution in two different containers. Both the metal rods are connected with ammeter by using one metallic wire. This is ammeter. So by using some metallic wire we connect it with an ammeter, and both the solutions are connected by a salt bridge. This is a salt bridge which connects both the solution. This is called salt bridge. So this is about the construction of electrochemical cell. A zinc rod is dipped in zinc sulfate solution, and a copper rod is dipped in copper sulfate solution. Both the metal rod, I mean the electrodes, are connected with one ammeter through some metallic wire, and both the solutions are connected by a salt bridge. Now after construction of this, after some time you will observe this zinc rod, it will dissolve in the solution. I mean this rod goes into the solution, and when the zinc rod goes into the solution, you know zinc exists as solid in the rod. When it goes into the solution, it will convert it to Zn2 plus ion by loss of 2 electron. So when the zinc rod dissolves in solution, when the zinc rod goes in solution, the solid rod will be converted to ion Zn2 plus by loss of 2 electron. And this 2 electron, when it lost by zinc, this 2 electron comes to the metallic wire. This is the direction of electron flow, and the electron directly goes to this solution. As you know, this solution contains copper 2 plus ion and sulfate ion. When the 2 electrons coming from zinc container, that 2 electron gained by the copper 2 plus ion, and when this copper 2 plus ion gain that 2 electron, then it will produce copper, and the solid copper will be deposited in this rod, and that's why the rod becomes thicker. Now this process will continue. The electron will flow from the zinc rod to the copper rod. Here, since zinc release electron, that's why it becomes positively charged, and that's why this rod is considered as positive rod, I mean anode. And here gain of electron takes place, that's why it acts as cathode, I mean negative rod. I mean the electron will flow from anode to cathode. When this flow of electron takes place, then this ammeter will show some deflection, and which indicates the production of electricity. But one thing you should know, since the electron, it flows from anode to cathode, the current will flow in opposite direction. This is the direction of current flow. I mean, current will flow from cathode to anode. The direction of electron flow and the direction of current flow both are opposite. So due to this transferring of electron from your anode to cathode, the ammeter will show deflection, and which indicates the production of electricity. I mean, by doing some chemical reaction, you know, here zinc release electron, I mean it undergo oxidation, and here copper gain electron, I mean it undergo reduction. I mean, due to this oxidation reduction reaction, some flow of electron takes place, and due to this flow of electron, the ammeter shows deflection, and which indicates the production of electricity. I mean, the chemical energy is now converted to electrical energy, and this type of cell are called electrochemical cell. Now, what is the function of this salt bridge? Actually, salt bridge, it is made up of filter paper. The filter paper, you have to dip in potassium nitrate solution, and you fold the filter paper. After folding the filter paper, you connect both the solution, and that filter paper will act as salt bridge. Again I repeat, you take one filter paper, the filter paper you dip in potassium nitrate solution, then the wetted filter paper you fold it and you connect both the solution. That filter paper will act as salt bridge. Now, what is the function of salt bridge? Since the filter paper is dipped in potassium nitrate solution, that means it contains some K plus ion and NO3 minus ion, I mean potassium ion and nitrate ion. Here zinc rod goes into the solution. When the zinc rod goes into the solution, zinc is converted to Zn2 plus. This is the solution of zinc sulfate, I mean it contains Zn2 plus ion and SO4 2 minus ion. When the zinc rod goes into the solution, when the zinc rod dissolves in solution, number of Zn2 plus ion will going on increasing, but sulfate ion remains same. So that's why the electrical neutrality will not be maintained. I mean, cation in this side you will get more, anion will be less. To maintain that electrical neutrality, some anion will coming from the salt bridge, and it will maintain the electrical neutrality. Similarly, here copper 2 plus ion goes to the rod. I mean, here deficiency of cation takes place, and to maintain that electrical neutrality, some cation will coming from the salt bridge, and it maintains the electrical neutrality. So the main function of salt bridge is it maintains the electrical neutrality inside the solution. If you do not maintain the electrical neutrality, the flow of electron will stop. You don't get the current for a long time. That is why to get the electricity, you have to maintain the electrical neutrality. I mean, number of positive ions should be equal to number of negative ions. Otherwise, flow of electron will stop. So that is why when you construct the electrochemical cell, you must have to use one salt bridge to maintain the electrical neutrality. So the function of salt bridge is nothing. Salt bridge maintain the electrical neutrality inside the solution, and second function, it completes the electrical circuit. So these two are the main function of your salt bridge. Now, how to represent this cell? You can represent the cell in a line. So how to represent a cell? In the anode, I mean at the anode, the zinc solid is converted to Zn2 plus aqueous. You can represent it like this way. Zinc solid is converted to Zn2 plus aqueous. I mean, here oxidation takes place, and that's why it is called oxidation half cell. And in this case, in the right side, copper 2 plus aqueous is converted to copper solid. Here reduction takes place, that's why it is called reduction half cell. To construct the electrochemical cell, there must be one oxidation half cell and one reduction half cell. Oxidation half cell should be left side, reduction half cell should be in right side. And both the half cell combined by the salt bridge. To represent the salt bridge, you have to put one parallel line like this. So this is the representation of this cell. So to represent the cell, you can write the cell like this way. That means here zinc acts as anode, copper acts as cathode. Like this you can represent. This parallel line represent the salt bridge, and this is called oxidation half cell, this is called reduction half cell. So this is about the electrochemical cell. Thank you.